exponents. So we want to simplify this expression. So what we got to understand is, what is a negative exponent? So it looks a lot worse than it really is. So the answer to this is 1 over x squared. Okay. And why is that true? What's the reason for that? And why would we even do it? There's some really cool things you can do by having this right here. If you look at this, they're equal to each other. They're the same. Well, the thing is, this means the same thing, but this one does it. The one on the left is without a fraction, and there's a lot of calculations that are much nicer to do when you don't have fractions. And there's many things that you can do to make this a lot easier to solve by not having a fraction in future stuff down the road. But let me show you kind of where this comes from. So if I had something like this, and I was asked to simplify it, x to the second over x to the fourth, what that really means is I got 2x's on top, 4x's on the bottom, all being multiplied, and then I can start reducing stuff, right? Those equal 1. And what I'm left with is a 1 on top and an x squared, okay? Well, what happens is we tend to do it with an exponent rule. So we learn this rule right here. If the bases are the same, how they're both on an x, I can just subtract the powers. You hear that a lot. Well, if I do that, okay, and I subtract the powers, you can see I already got the answer up there, and I do this, it's the top power minus the bottom power, numerator divided by the denominator, and so I end up with x to the negative 2. But I know that this is really 1 over x squared. So because I use this kind of shortcut exponent rule, I end up with these negative powers. But all it really means is I had more x's on the bottom than I did on the top. Okay. So if I write something like this, how would I write this as positive exponents? Well, with that x to the negative 5, all that really means is I've got 1 over x to the 5th, and then I'd multiply straight across, and that's all I got. It's just a way to rewrite the same idea. Okay. So y to the negative 8th, well, that's really like 1 over y to the 8th, and then I multiply across. Those are not like bases, so I can't actually multiply the x and the y together. They just get multiplied by being put next to each other. Okay. Now here's one that gets a lot of people. That negative 4, because I don't see any parentheses, is only on that x. So really the 5 stays where it's at, and then the x to the negative 4 turns into 1 over x, and I get this. Okay. And you can see I put the x first just because you tend to write things in alphabetical order. All right, so now what happens when they're on the bottom? Okay, well, it goes to the top. It's not really doesn't just go up there. That's what the end result is by using the shortcut of a rule. Let me show you what's going on with this. So we end up with just x to the third. So let me give you a quick reason of why this works. So is you're basically using multiplying by the reciprocal. So if you remember, something what this really means, what I do know is it does equal this. The denominator is really 1 over x to the third. And then dividing by a number is the same as multiplying by its reciprocal. So if you go ahead and multiply straight across, I get this. Okay? And that's where that comes from. All right, let's look at this for a second and see what we can do. So this is not too bad because none of the variables are the same. So the question, all we're really doing is dealing with the negative exponents. We can't leave answers to negative exponents. One turns into positive exponents. So this x to the negative third and this k to the negative 5. So really, because what I've learned, right, these exponent rules are just kind of like shortcuts, is that if it's in the numerator, it's really in the denominator, right? It's the reciprocal to it. So this k to the negative 5 is going to go to the top, and this x to the negative 3 goes to the denominator. Okay. Let's get another one. So looking at this, see the w squared and the k to the 8th, those are positive exponents. They're going to stay right where they're at. Okay. So everything's going to drop down to the numerator. Right? Remember, a negative exponent means I just really have them in the denominator of the fraction. So this is one that also starts to get people. If you look at this, that's a negative 7. That is not an exponent. That's not going to go anywhere. Just that y to the negative 5 goes up to the numerator, and then that's what I get right there.